Good morning. In today's lecture, we discuss algebra of partial derivatives. In last lecture, we see what is partial derivatives and some examples on partial derivative. Are you understand the definition of partial derivatives and examples on it? Okay. So in this lecture, we discuss algebra of partial derivatives. It's very simple. It is a theorem. Let S be a non-empty open subset of Rn. If G is a function defined from S to R. Let A belongs to A is equal to A1, A2 up to An belongs to S. And if dou f by dou xi at A and dou g by dou xi at A exists, that is at partial derivative with respect to x and partial derivative of with respect to partial derivative of g with respect to a is exists, then we have to prove that dou xi, dou by dou xi, dou f plus g at xi operated on a is equal to dou f by dou xi at a and dou g by dou xi at a. Similarly, f for the function f plus g, f minus g, alpha f into g and f upon g. Okay, we have to solve this. We solve this theorem one by one. First one, consider the proof. Let f and g are the function defined from Rn to R. Okay, they are scalar valued functions, and we have given that dou f by dou xi at A and dou g by dou xi at A exist. So what is definition of dou f by dou xi at A? Which is limit h tends to 0, f of a1, a2 up to ai plus h, an minus f of a1, a2 up to n upon h. ith डेरिव्हेटिव्ह कॅल्क्युलेट केलाय आपण इथे dou f by dou xi for g of a, that is limit h tends to 0. Coordinates of a are a1, a2 up to an. That's why we used here a1, a2 up to n. G of a1, a2 up to ai plus h, an minus g of a1, a2 up to n upon h. These are only definitions of dou f by dou xi and dou f by dou g by dou xi at a, which are exist or I running from 1 to n. Now we have to consider our first part of our theorem. Dou by dou xi operated on f plus g on a. Now we have to, our operator is here f plus g is our operator. So we are operating f plus g on a1, a2 up to ai plus h, an minus f plus g operated on a1 plus a1, a2 up to n upon h. Now f plus g, since f is a linear function, f of a1, a2 up to an plus g of a1, a2, ai plus h up to an minus here again f of a1, a2 up to n minus g of a1, a2 up to an. Now separating the limit, taking f of a1, a2 up to ai plus h an minus f of a1, a2 up to n upon h in the first limit, and limit h tends to 0, the function g will taken in the another limit. But the limit h tends to 0, f of a1, a2, ai plus h up to an minus f of a1, a2 up to n upon h. This is definition of dou f by dou xi at a, and the second part of the limit is the definition for dou g by dou xi at a. So this is quite simple. We solve the first part of that theorem. Dou by dou xi operated on f plus g at a is equal to dou f by dou xi at a plus dou g by dou xi at a. Okay. Now second part is about only subtraction. Addition sign will changes to subtraction. F plus g changes to f minus g. Other part is same. Okay, read this part. You will easily understand this. Now we go for the third part. Dou by dou xi operated on alpha a. Now our operator is alpha f operated on a. So limit h tends to 0. Alpha f a1, a2, a2 ai plus h, an minus alpha f operated on a1, a2 up to n upon h. So now alpha f. So alpha operated on f of a1, a2 up to ai plus h n minus alpha, taking alpha outside, f of a1, a2 up to an upon h. Now alpha is scalar, taking outside the bracket alpha in bracket f of a1, a2, ai plus h, an minus f of a1, a2 up to n upon h. So taking alpha is constant, taking outside from the limit, and the in limit remains. So you know, in the in the this part of limit is the definition of dou f by dou xi at a. So dou f by dou xi alpha f into a is equal to alpha into dou f by dou xi at a. It's quite simple. Okay. Now next part is f into g operated on a. Okay. So here one adjustment is necessary. This adjustment is studied in limit and continuity part. Same adjustment is used here for this part. Limit h tends to 0 operator is here f into g. So f into g operated on a1, a2 up to ai plus h an minus f into g operated on a1, a2 up to n upon h. Here we separating this f operated on that into g operated on function. F operated on a1, a2 up to n, g operated on a1, a2 up to n. Okay. Now limit h tends to 0. We add one term f of a1, a2 up to a plus h into g of a. First term is same. We adding this new term minus f of a1, a2 up to ai plus h an into g of a1, a2 up to an plus f of a1, a2 up to a plus h an into g of a1, a2 up to an. We add and subtract this term. First and last term will be same is in the example, and we adding these two terms f of a1, a2 up to ai plus h up to an into g of a1, a2 up to an, adding and subtracting this term. Now here we take f of a1, a2 up to ai plus h an is common from first two terms. We take common f of a1, a2 up to ai plus h an. Then bracket will contains g of a1, a2 up to ai plus h an minus g of a1, a2 up to an. Taking g of a1, a2 up to an common from remaining terms, that is term number 3 and 4. The bracket contains f of a1, a2 up to ai plus h an minus f of a1, a2 up to an. Okay, upon h, this whole term divided by h. Okay, so now f of a1, a2 up to ai plus h an into g of a1, a2 up to ai plus h an minus g of a1, a2 up to an h. Okay, we separating the limit. First term separated, and here limit h tends to 0. This second term, we separate these two terms. Okay, so in first term here f of a1, a2 up to ai plus h an, and the first bracket is the definition of dou f by dou x at a plus here g of a1, a2 up to an is remains same, and the second term is dou f by dou xi at a bracket. Second bracket contains the definition of dou f by dou xi at a. That is f of a1, a2 up to n means what? F of a, since coordinates of a1, a2 up to n are coordinates of a, and here g of a1, a2 up to n is g of a. So we prove this part. Dou f by dou xi operated on f into g at a is equal to f of a dou g by dou xi at a plus g of a dou f by dou xi at a. हे तुम्ही लिहिलात ना व्यवस्थित, हीच तुमच्या लक्षात येईल असं एक्सप्लेन करण्यापेक्षा फक्त इथे आपण एका टर्मची ऍडजस्टमेंट केलेली आहे, तेवढी ती लक्षात ठेवणं गरजेची आहे. ती टर्म, तर ती टर्म कोणती आपण ऍडजस्टमेंट केलेली आहे इथे पुन्हा बघा. ती स्टेप म्हणजे आहे f of a1, a2 up to ai plus h an into g of a1, a2 up to an. ही टर्म ऍड केली आहे आणि तीच टर्म सबस्ट्रॅक्ट केली. इथे आपण दुसरी टर्म पण घेऊ शकतो, g of a1, a2 up to an into f of, or g of a1, a2 up to ai plus h an into f of a1, a2 up to an. ही टर्म सुद्धा ऍड सबस्ट्रॅक्ट करून सेम थिअरम सॉल्व्ह करू शकतो. ओके, असाच या थिअरमचा लास्ट पार्ट आहे f इंटू f अपॉन g चा. इथे पण सेम आहे, सुरुवातीला f अपॉन g ऑपरेट केलं याच्यावरती, f अपॉन टू a1, a2 up to n आणि g वरती ऑपरेट केले, त्यांच्यात क्रॉस मल्टिप्लाय केले. क्रॉस मल्टिप्लाय केल्यानंतर तुम्हाला ते सिम्प्लिफाय होईल. वाचून बघा, समजेल. नाही समजलं तर मग मी सांगेन नंतर. ओके, बट इट इज क्वाइट सिम्पल. ओके, नुसतं वाचल्यावर सुद्धा लक्षात येणारी ही गोष्ट आहे. बघा. थँक्यू.